Hey makers, welcome back to Hub360 Embedded Sphere, your favorite stop for building real-world IoT and embedded projects. In today's tutorial, we are building a voice-controlled robotic arm powered by the ESP32 and controlled via Bluetooth using the MIT App Inventor. This project allows you to move each joint of the robotic arm, base, shoulder, elbow, and gripper, simply by speaking voice commands like base left, elbow up, or open grip. Let's get started. The components used in this project are the ESP32 development board, 4 DOF robotic arm kits, two breadboards, and your MIT App Inventor mobile. Alright, now let's connect our Servo Motors to the ESP32. First, we start with the base servo. We connect the signal wire of the base servo to the pin 12 of the ESP32. Then we connect the VCC of the base servo to our 5 voltage supply. And then we connect the ground of the base servo to the common ground. Now let's connect the shoulder servo to the ESP32. Here's the shoulder servo. So first we connect the signal wire of the shoulder servo to pin 5 on the ESP. And then we connect VCC to the 5 voltage power supply. Then connect the ground to the common ground. Now we connect the elbow servo. Here's the elbow servo. So we are connecting the signal wire of the elbow servo to pin 16 on the ESP. Here's the signal wire. Goes to pin 16. Then the VCC and the ground, we connect it to our power source. VCC goes to the 5 voltage supply and ground to common ground. Now we connect the gripper servo to the ESP32. First, look at the gripper. This is the gripper servo. So first we connect the yellow wire, which is the signal wire, to pin 13 on the ESP. Pin 13. And then we connect the VCC to our 5 voltage supply. And then we connect the ground to common ground. Now let's connect our 5 voltage supply. So positive of the 5 voltage supply goes to the positive wire of the servo. And then negative of the 5 voltage supply goes to ground of the servos. So important things to note: ensure ground, the ESP32 ground, the 5 voltage supply ground, and the servo's ground are connected together. This is critical for proper signal referencing. Do not power the servo from the ESP32's 3.3 voltage pin, as it cannot supply enough current. Now let's break down the code step by step so you understand how each part works. Bluetooth serial.h enables serial communication between the ESP32 and your smartphone via Bluetooth. ESP32 Servo.h allows smooth control Servo Motors connected to the ESP32's GPIO pin. Now in the servo pin definitions, each servo is connected to a dedicated GPIO pin on the ESP32. the base servo to GPIO pin 12, the shoulder servo to GPIO pin 5, the elbow servo to GPIO pin 16, and the gripper servo to GPIO pin 13. These pins send PWM signals to control the movement of each servo motor. Now in the Bluetooth setup, we create a Bluetooth serial interface named the ESP32 Arm, which will appear in your MIT App Inventor when pairing. This allows the app to send single character commands like 1, 2, 3, and R wirelessly to the ESP32. In the servo initialization, each servo is attached to its respective pin with minimum and maximum pulse widths 500 to 2400 microseconds. This defines the full movement range between 0 degrees to 180 degrees for each servo. Initial servo angles are then set. In the reading commands from Bluetooth section, the ESP32 continuously checks if a new character command is received via Bluetooth. Once a character is read, like 1, 2, or R, the switch statement identifies which action to perform. In the movement control logic, each case in the switch block adjusts the servo angle and moves the respective joints. For example, 1 rotates the base left by decreasing its angle. 2 rotates the base right by increasing its angle. 3 and 4 moves the shoulder up and down. 5 and 6 control elbow movement. 7 and 8 open and close the gripper. The constraint function ensures angles remain with safe limits 0 to 180 degrees or 30 to 120 degrees for the gripper. In the reset command section, when the command R is received, all servos return to their neutral position, perfect for resetting or calibration. Now let's go to the step size. Determines how much each servo moves per command. A smaller value like 5 gives final slower movement, while a larger one like 20 gives faster coarser movement. Power on the ESP32 system. Open your MIT app on your phone. Pair with ESP32 Arm from your Bluetooth list. Tap Connect in the app. Now press the Speak button and say commands like base left, elbow up, open grip. Watch as your robotic arm responds instantly.
Elbow up, elbow down, show forward, open grip, base left, reset, show front, show back, elbow down.
In this project, you've learned how to use ESP32 Bluetooth for wireless control multiple servos simultaneously, build a custom voice control app using MIT App Inventor. Now your robotic arm obeys your voice commands. No buttons, no cables. All components used in this project are available on hub360.com.ng. Like this video if it helped, subscribe for the next tutorial. Until next time, keep building, keep innovating. This is Hub360 Embedded Sphere, helping you bring your ideas to life.